Welcome to Tech Talk Podcast, Episode 4. This is our regular podcast discussing the various challenges that are faced by the power industry and how technology, and in particular geospatial technology, can be used to address them. Today, I'm very pleased to be joined by Andy Hewitt, our Senior Account Manager, and we're going to talk about today's topic, which is rapid vegetation. So, Andy, how are you today?
I'm doing very well. How are you?
Very good, thank you. Thank you for joining the podcast. So we're talking vegetation management, and before we get on to rapid vegetation, let's just talk for a minute about vegetation management. So, I mean, it's a huge topic, of course, for a network operator. It's usually one of the most expensive operational expenses they have to deal with. It's usually one of the biggest causes for outages, so it's a big deal. But apart from what I've just mentioned, what are kind of the issues that utilities who are using LiDAR or some sort of geospatial technology to manage their trees and their lines, what are some of those issues that they're facing?
So, I mean, in our experience, a lot of the pain points are about making that data actionable. We can do the LiDAR surveys, we get the information back, but then it's how do we get that out into the field? So there's some issues there on kind of formats and feeds, but also on kind of turnaround times. If we do a survey today and you want the full vegetation clearances to your kind of PLS CAD model, that can take months.
Okay.
So being able to get that back into the hands of the vegetation contractors to go out and manage those critical risks to the network is a big deal.
And why is that? Is that because it doesn't work with their cycles, or because trees are growing in that time, or all of the above, or is it something else?
A bit of everything, to be honest. So it's if you do the LiDAR survey today, the trees are growing every day until you go out and fix them. Being able to get those kind of critical infringements managed immediately means that they're not sat there kind of posing an outage risk to the network. And also just being from a compliance perspective, anything that kind of needs to be done on the network and kind of has been kind of found needs to be actioned pretty quickly.
And I suppose that's a neat segue into what we're talking about, rapid vegetation management, and I guess that's the need. That's what we're getting from industry is something which they want to have addressed. Perhaps you could explain to me and to our listeners then what this concept of rapid vegetation is.
Absolutely. So rapid vegetation is kind of our approach on getting this information back to the vegetation managers as quickly as possible. What does that mean in reality? Well, after a LiDAR survey flight, we will take the LiDAR information, we will extract that for vegetation purposes, and then we can run some clearances to the as surveyed positions of the conductors. So these zones might be your kind of compliance zones. They might be compliance zones with some kind of larger buffers around them for management purposes. And they might also have some larger buffers around them, so you can kind of start planning what needs to happen next year, the year after, that kind of thing.
So let me just get my head around that. So that would mean you could apply sort of a traffic light system to it. You can have the critical issues that you should deal with but don't have to be dealt with today, and those which you may or may not want to deal with, but you need to know where they are because they're likely to be a future risk. That kind of setup.
Exactly that. Yeah.
Yeah. Okay.
And one of the kind of extra bits we can do here is, as well as just using the kind of the as surveyed conductor position that we got from that survey, we can also pull in the existing, if there's an existing PLS CAD model there, we can pull in the kind of the max blowout or the max sag of those lines and run the vegetation clearances to those as well. So if you've got kind of long spans in windy conditions, we can account for that in the rapid vegetation process.
Makes sense. Okay, and let me just get my head around. So what we're saying here is this effectively means that you could be running this as part of a sort of synergistic project, if you will, where you're looking to do something like confirming thermal ratings or some sort of engineering study, but you're not having to wait until all that modeling at the end's done before you can get the clearances to trees and everything else that you're going to do. How quickly are we talking?
So it ranges sort of 2 to 4 weeks.
And then just to give that comparison point, sorry to jump in there, if you didn't do that and you did it as part of an engineering study, we're talking months, I presume. We're talking what, sort of 2, 4, 6 months into the future, depending on size of the project?
Exactly that. And so even with the modeling, if you've got 1 or 2 lines, that might be okay. You can afford to wait for the engineering to finish. But if you're kind of doing this on a large scale network, waiting for all the engineering to finish before you can do the vegetation, trying to prioritize that work, it can end up a long time away from the initial survey. So this is a good way of getting that vegetation data straight to the crews and getting those kind of issues mitigated.
Well, yeah, I mean, it sounds like a sensible approach to get the data, but to give some context around this, I mean, what's had to occur for this to be done so much quicker than before?
Yeah, so some of the things that we're not doing in this kind of study is the vegetation clearances will be carried out against the as surveyed conductor or a previous PLS CAD model.
Okay.
So the towers always are where they are, unless there's any kind of capital changes. But obviously the conductor position changes day by day. So we can do against the as surveyed, so which would give you clearances on a typical day, the day we flew over, or we can do them against those kind of extreme positions if you've got issues where that needs to happen. The LiDAR itself is exactly the same LiDAR that we're going to use for the engineering study. It goes through the same quality control checks for that. It's just that we split it off before we go and do that engineering work.
So the LiDAR is as accurate as it's ever been. LiDAR is the LiDAR. It's just that the way we treat it is different. We're using a buffer here rather than the modeled CAD wire position.
Exactly that. Yeah.
Got you. And so this, I mean, this to me sounds like it's a pragmatic choice that the utility makes here. You know, what's more important? Do they take the PLS CAD engineering model and use that for doing their clearances, whether it's in North America for FAC 003, or if it's, you know, in a different region in the UK, for example? So do they take that engineering model and use it, which has that time penalty, or do they take a buffered approach where they're taking what's the biggest risk to my network now, apply a sensible buffer and use that to make the same assessment? I guess the outcomes are likely to be similar, but the methodologies, that's where it splits.
Exactly. And the differences can be small, but also with the rapid veg, you can add in kind of extra zones. So you might be able to do like a bigger clearance than maybe you probably would have done in the engineering study. And you can look there for kind of looking and trying to plan ahead for reducing out of cycle work in the future.
Well, let's talk to that. So, I mean, in a couple of sentences, what would you say are the key points here?
So I think the biggest thing on here is in the name. It's the rapid veg. It's getting the outputs to the utilities as soon as we can, without kind of hindering the process by creating these new models. We could still do the full engineering vegetation studies at the end after we've done that, but it gives the guys a chance to go out and manage these critical issues that might cause issues on reliability or outages, that kind of thing.
Totally agreed. And I suppose, like you said before, if you can understand the current situation at the earliest point, it means you can plan for that situation, which means you could be more proactive in how you manage trees. And that can only be a good thing in terms of reducing any out of cycle cutting you have to do, which is obviously quite expensive. But more importantly, you can manage within your cutting season your highest priority, and that, you know, that surely is the most important thing of all.
Yeah, I think it's just being able to understand the state of your network at that point in time, and knowing that is the state of the network. That when you send a contractor there, there is an issue there. It hasn't already been managed, and kind of avoiding wasted time, planning your vegetation priorities and getting those sent out to the crews.
I picked something up there, which you said, which is interesting, is avoiding wasted time. And I know from previous conversations we've had that there's, you know, in general, when you use LiDAR, there's a risk that it might flag a false positive. So you know, which is always better to be more conservative, but there's a risk that you might send a crew there and actually there's not something there. You know, it's a wire return or something else, a temporary object or whatnot. How does this system deal with that? I mean, does that mean you're going to be doing that more often, more frequently, or not at all?
Well, that kind of comes into how people use the data. So most utilities that are kind of taking this rapid vegetation approach are actually using Cadence, our online visualization platform. So we deliver this data through Cadence. It's published straight from the production facility, and as soon as that becomes available, you can go and view it and look at those issues on the network. Within there, you've got the terrain, you've got the imagery if it's been collected, and along with the LiDAR and the infringements, obviously. In there, you can go and assess visually the infringements that have been found, and maybe plan how you might go out and manage those, whether it's access, looking at what the environment that it sits in, what kind of does the material need to be taken away afterwards. It provides like a really nice way to see what's going to be there before you get there, and make sure that everything's kind of resourced appropriately.
And that, I'm assuming that means that you would see then if it was I don't know, an undercrossing wire or something which was flagging, you'd be able to see that was the issue ahead of time. So you wouldn't need to go effectively.
Absolutely, yeah. So
yeah.
By being able to visualize it, you can see if there's maybe a discrepancy in those errors, or maybe it is a critical issue that kind of needs calling in.
Well, great, Andy. Thank you for talking about Rapid Veg. It's really interesting, and I hope everyone listening has enjoyed the conversation and learning more about that concept and that approach. I mean, I totally see this. There's a lot of questions we get all the time about utilities wanting to get the data sooner, and that being part of the the real value case in using it for vegetation management. And I hope what we've talked about today will provide some more information. But if you do want to learn more, please do get in touch. You can certainly contact us at www.nmgroup.com and drop us an email from there. Thanks for listening.